Hi, I'm going to explain about a high pass filter. So high pass filter function is it will allows only high frequency and stop the low frequency noise signals. So you can see this here. This is the high pass filter circuit. Just by using capacitor and here you can see this by using capacitor and that is resistor we can pass the high frequency signal and stop the other unwanted signal. So I'm assuming here you can see this here this is the high frequency signal. This is I'm assuming. So this is the image. I'm assuming this is x of t. So after conversion from that is image to em wave, just assume this is an high frequency signal x of t having high frequency. So while giving high frequency, what will happen? You will check it. So according to capacitance reactance, so here you can see this, the reactance RC is equal RC reactance RC. You can say this, the reactance RC is equal 1 by 2 pi FC. FC. So here I am assuming we are giving that is high frequency. Just assume the high frequency is that is F called infinite frequency. Just assumption. High frequency are giving here. So therefore that is 1 by 2 pi F is infinite multiplied with capacitance. 1 by infinite multiplied with something that is 1 by infinite. So that is equal 0. 0 ohms reactance at the capacitance that is 0. Here you can see this. So means it will while giving across this capacitor, you can see this across this capacitor. So the reactance is 0. So means while giving high frequency, so it will pass towards it allows. So means you will get the output across this high frequency signal. So while giving low frequency, what will happen? You will check it. Here I can say this. I am assuming here this this is the high pass filter. You can say this. Just capacitor and resistor. By using this, we can stop other low frequency noise signal, and it can allow only high frequency signal. This is the resistance and this is the capacitance. So I am giving again here the input frequency is low frequency, that is F. F value is low frequency. I am assuming just assumption zero frequency for this image. So I am giving this. Then according to reactance, that is here it is according to reactance. You can see this. You can say this. Therefore, R is equal. Here you can say this. You can say this. R reactance R is equal 1 by 2 pi FC. So therefore 1 by 2 pi F is 0. 0 into C. 1 by 0 into something equal 1 by 0. 1 by 1 by 0 means infinite ohms. The reactance while giving zero frequency, the reactance across the capacitor is you can see this reactance across the capacitance is that is infinite ohms. Infinite. So therefore it will stop while giving the low frequency signal. So the reactance across the capacitance is infinite ohms. So that's why it will stop by the capacitance. So you may not get anything across the output here. So like this, while giving zero frequency, that is low frequency, it will stop by the capacitance. While giving high frequency, it allows by the capacitance. So that's why it is named as that is high pass filter. High pass filter function is always it allows. The filter is nothing means. So always the filter function high pass filter function, just it allows high frequency and it will stop the other unwanted low frequency noise. That is the high pass filter function. High pass filter function is, it will allow high frequency and stop the other unwanted signals everywhere. Even if you go for low pass filter, it will stop the low frequency and it will allows the other unwanted high frequency noise. So this is the low pass filter. So students, by using just capacitance and resistance, we can stop other unwanted signals and we can allows our required frequencies. Just you can see this, you can observe this, only capacitance and resistors. So coming to the application, you can see this everywhere it requires, if you go for radio communication or else that is satellite communication, everywhere in communication systems the filters are required. So it will allows high frequency, high pass filter allows only high frequency signal and it will stop the other unwanted low frequency noise. Everywhere it requires. Thank you.